Welcome guys once again. This is Mr. Ndabezita, and we are going to look at polymorphism principle in Python. And I think this is very important that we understand this principle of polymorphism. And what I'm going to do there, as you know what polymorphism is, taking many forms, a method that can take different forms and so on. This is polymorphism, but I think it will be best described and defined in terms of a code. So what we are going to do first, we are going to import, and we are going to import math, so that we can have the different mathematical equations and everything that goes along with that. So the first thing, remember, we are dealing with object-oriented programming. We will define a class which I will call a figure, and I'm going to define a function inside of this class which I will call calculate area. Very good. And this method, I'm not going to pass in self there. I'm not going to do that. But what I'm going to do there, I'm just going to return 0. Very good. So this is what I have. This is a class, has a function which I call calculate area, and it will return a 0 there. Very good. And then secondly, I'm going to have a class which I will call a square, because a square is a figure, therefore it will inherit from a figure. Very important. And I'm going to define a function in there, and this would be a constructor. I'm going to use the init, and what I'm going to pass in there, the constructor will accept one argument which I will call let me check, side value. So let me just call it a side value there. So I'll have my side value. Very good. So this is a constructor of this class, and what is it that I want to do? So I just want to say self dot side will be equals to the side value that you pass in there. Nothing is new with this. So secondly, what I'm going to do in there is to define area. So I'm going to define calculate area. So I am overriding the base method. So calculate area. Very good. And then what is it that I'm going to pass in there? I'm going to pass in self. Very important. I'm going to pass in self there. Right. And then what is it also that I'm going to do this? So I'm going to just return, and what I will return in there is self dot side, which will be equals to what? Which will be equals to the side value. Where is it now? Which will be equals to the side value there. Okay, let me not say that. Let me say self dot side multiply by self dot side, because this is how you would calculate the area there. So remember this method, I am overriding the base method, and in there, when you call this method, what it will do, remember, when you instantiate a constructor, you will pass in the side value, and that side value will be the value of the side. So it will multiply side by side and it will return a value there. So nothing is mysterious with this. So I'm going to define another class. So in here we are having some problem, and let me just pass in self there. Very good. So when I'm here, what I'm going to do is to have another class which I will call a triangle, and I know that a triangle is a figure, therefore it will inherit from a figure. And let the triangle have a definition of a function constructor, and this constructor that I will have in there, let it accept some few arguments. So the first one will be a value and a b value and a c value there. So those are the three parameters, and I'm going to say self dot a, and I'm going to assign it a value of a value, and I'm going to say self dot b, and I'm going to assign it a b value, and I'm going to say self dot c, and I'm going to assign it a c value there. So everything seems to be fine. A c value. Okay, a c, let me just fix this. This is supposed to be a small c and a capital V there, so that I can say c value there. All right, so I want to show you something in here. You can see that in here, when you instantiate a triangle, I'm creating a variable a, and whatever that you pass in there will be stored inside a, whatever you pass in b, and also in c. So this is very important that we should note that. So now I'm going to override the base method. And how am I going to do that? I'm going to define calculate area, there it is, and then in here what I'm going to do, I'm going to say, in fact I'm going to get the sides of a triangle. So I'm going to say a is equals to self dot a, very good, and then I'm going to say b equals self dot b, very good. I'm going to say c equals self dot c. Right, so what is it that I'm doing in here? I am creating variables a, b, and c, and I'm taking whatever that is inside of a, which you have in essence provided when you constructed your triangle, and I'm storing them inside of the containers a, b, and c. So this is me trying to get the triangle sides. So this is a triangle. So this triangle has whatever the triangle may be: isosceles, scalene, right angled triangle, and so on. So this would be the size of that triangle. The specificity is not provided there as to whether the triangle is whatever that it is. But I know one thing, that a triangle, remember in here, a triangle has the sides a, b, and c. It is a triangle, and there are different triangles that we can talk about. But this one that we are trying to talk about, if we calculate the area, first of all, I will calculate the perimeter of this triangle. And I will say that the perimeter of this triangle, remember, the perimeter is sum of all the sides. So I'm going to say A plus B plus C. But in this type of a triangle, the sum that you find in there, you have to divide it by 2. And that would provide you with the perimeter of this triangle. And then secondly, when I calculate the area, I'm going to say math dot, and in here I'm going to look for the square root, and I'm going to take the value of P and I'm going to multiply that by P minus A, and then I'm going to multiply that I'm going to multiply that by P minus B, and then I'm going to multiply again by P minus C. So this would be the way in which I can calculate the area there, and then I'm going to return the area. Very, very good. So let us look at what we have done in here. So we import math so that we can have access to the square root. As we saw, I'm having a class which is called a figure. There is a method in there, calculate area, that returns a 0. So I'm going to override this method because it accepts no arguments. I'm creating another class square because a square is a figure, therefore a square will inherit from a figure, therefore it will have access to this method. But in a square, what I'm doing in there, I am defining a constructor. Here it is. So the constructor accepts one argument, which is a side, and then I am declaring a variable in here, side, and whatever value you will pass when you instantiate a square, that value will be passed there, will be stored as a side, right? And then I am defining a function because this was a constructor. I am overriding the base method, and in here, what is it that is going to happen? I'm taking in the side. There it is. You see it points to the same memory location. I'm taking in the side, multiplying by the side, because that is how you would calculate the area of a square. And then that is fine. I'm fine with this. I'm creating a class. A triangle is a figure. It will have access to this method. I'm having my constructor in here that accepts 3 things: A, B, and C values. And then I am creating some containers. The value that you pass in there will be stored inside A, B, and C. And then what is it that I am doing there? I'm saying, okay, this is all what I have. So in my constructor, I have my A, B, and C in this class of a triangle. And then I'm overriding area. And then what is it that I'm doing in here? First of all, I am going to the values of A, as you can see there, and I'm storing them inside a new variable called A, B, and C. And then I'm calculating the parameter in there as that, and then I'm calculating the area as that, and then I am returning the area. This is something very, very basic. Something very basic. And then now what is it that I'm going to do there? And remember, indentation is very, very important. We should never and ever forget indentation. Very, very important. So what I'm going to do there is to create an instance. So the first one is a square, because a square is a figure. So I'm going to have a square that I'm going to equate to a square. Does a square accept anything? Yes, one parameter, which is a side. and then let me just have a printout in here that says square area, and then I'm going to say okay, square dot calculate area, and then it will calculate the area for me. And then secondly, I'm going to create a triangle which is equals to a triangle, and a triangle accepts three things, so I'm going to provide 3, 4 and 5 there. And then what I'm going to do is to have a print, and then I'm going to say triangle area, and then what I will do there, I will just say triangle dot calculate area. There it is. And then let's check what is going to transpire. So when we are in here, let us try to check what is going to happen in here. So when I say calculate area there, what it will do, it will go inside of your square and it will invoke this one. So in here, let me just say let me concat there and say units squared, and also in here let me just concatenate and say units squared. Right, so this is what I want to have. Let's check whether we are going to have some problems in here or whether we will not. Let us just try to check. So I'm using concatenation in here, and expected type float got a string instead. Do you see that we are having some problems in here? So how do we fix this? How do we fix this? Let's run and see whether we will have some problems. Yes, we will have some problems in there. So let me just quickly come here and just try to comment this one. Sorry, let's comment this one and run this once again. We are still having a problem, so let's not add these things. Let's not add these things. They are going to create some problems for us. So let us try to check there. So let me check. Oh, I forgot to have a print in here. Right, so let's try to run this. Square area is 4 and triangle area is 6.0. So remember, in here it cannot convert a float to a string and so on, hence we cannot add or concatenate a string in here. So guys, I hope you understand what has happened in here. I hope you, more especially on this part, I hope you understand on this part, and also you understand how to find this area and what is happening in here. So here we are using a lot of polymorphism. So as you can see that this method takes in many forms. So in here, look what it does, and in here, look what it does in here. So this is what we call polymorphism. A method taking in different forms in order to perform a certain functionality. So this is something worthy of noting, something that requires a lot of practice. So guys, I will see you tomorrow again.